Good morning, students. The previous classes we have already learned the phenomena of reflection and how does the spherical mirrors produce the image of an object when the object is kept at different places and the different kinds of spherical mirrors and their uses. And in this video we are going to describe about another phenomena of light is known as refraction of light. And we already know that the light seems to travel in a straight line. The characteristics of light we have already learned that it has the wave nature and the particle nature of light. What do you mean by refraction of light? Let's see an example in order to understand the phenomenon of refraction in a best way. So for that, when you might have observed that when a pencil is partly immersed in the water, the portion that immersed in the water seems to displaced at the interface of air and water medium. And how does it happen? Or maybe the light reach from the portion which is immersed in the water will be slightly displaced. So we can see that the pencil is slightly dispersed, the portion above the water and the portion below the water. And if we explain or if we observe the same thing at a different media like water, kerosene, mustard oil or any other different kinds of media, then does this displacement is same in every medium? We may not observe this displacement of pencil which is immersed in a liquid medium may not be same in every medium. And so here we can explain that, or here we can say that at the interface of the two media like air and water here, and the object, the light is slightly displaced, and this displaced in a sense that the light slightly bent as it passes from one medium to another. So, and this bending of light is known as the refraction of light. And the refraction of light is not same in every medium. So it is different in different medium, and it depends upon the refractive index of the medium. Then what do you mean by refractive index? The refractive index is another term that explain the ability of the medium to bend the light as it passes from one medium to another. We already learned that the light travel from one medium to another will change its direction, and this change in the direction of the light given as a pair of medium is given as the refractive index of the mediums. The refractive index of the medium can be related to the physical quantity, that is the direction of propagation of light in that medium. So the speed of light in air or vacuum, we know that it is 3 into 10 raised to 8 meter per second, and this value can be taken as the absolute value, or we call it absolute refractive index of the medium. Then when we compare this absolute refractive index of the medium with another one, then we can find out the refractive index of any other two pair of mediums. For example, if we consider two mediums, air and glass, So as the light passes from obliquely air to the glass, then the speed of the light will change. Okay, the speed of light in the air, it has a particular value. As it passes from air to glass, the speed of the light will change. And the change in the speed, that as it travels from one medium to another, and that is taken as the refractive index of the medium, or that is the difference in the refractive index of the medium. This is a glass slab, and the air passes from obliquely enter in the glass. It passes through the air, and it is enter in the glass slab. So here, if you draw a normal to the point of incidence here, okay, and the angle between this normal and the incident ray, that gives the angle of incidence. So as the light enters into the glass slab, what happens? Density of these two media are different. The density of air and the density of glass are different. So let the air can be taken as the medium 1 and the glass taken as medium 2. So the speed of the light in the medium 1 is V1 and the speed of light in the medium 2 is 2. So as it enters the glass, and the direction of propagation of the glass changes like this. Now here, this is the angle between the normal and the refracted ray, that is R. Okay, so angle of incidence and angle of refraction. So here, see, the direction of the light changes as it enters into the glass. Here these two, medium 1 and medium 2, okay, and so the refractive index of the medium 1 can be taken as N1, and the refractive index of the medium 2 can be taken as medium 2. So the speed of light is different in two different mediums. The first medium is V1 and second medium is V2. The refractive index of the medium 2 with respect to the medium 1 is given as the ratio between the speed of the light in these two mediums. So the refractive index of the medium 2 with respect to medium 1. What is that? That is the ratio of the speed of the light in these two mediums. Speed of light in medium 1 divided by speed of light in medium, that is equal to the speed of the light in medium 1 is V1 divided by the speed of light in medium 2 is V2. V1 divided by V2. By the same argument, and we can find out the refractive index of the medium 1 with respect to the refractive index of the medium 2. So that can be represented as N12. And what it would be? That is the speed of the light in medium 2. Speed of light in medium 2 divided by the speed of light in medium 1. So that will be speed of light in medium 2 is V2 divided by speed of light in medium 1, that is V. If the medium 1 is air, then the speed of light in that medium is known. Okay, that is 3 into 10 raised to 8 meter per second. So then, if the medium 1 is air or vacuum, then the refractive index of that medium is taken as the absolute refractive index. If the medium 1 is air, then we can find out the refractive index of the medium 2. That is, so then that can be represented as Nm. That is the refractive index of the medium 2. So that is equal to, with respect to 2 is what? The speed of the light is equal to light in air divided by speed of light in medium 2. So the speed of light in the medium air, that is equal to c, and the speed of light in the medium 2 is v2. The next, refraction of light through a glass slab. So here a glass slab, A, B, C, D, and an incident ray of light incident on the side of the glass slab A, B obliquely. And as we know that the previous cases classes we have learned that the ray of light coming from a source is the incident ray, and this could be the direction of the light. And here this is the point where the incident ray that is the point of incidence. And now if you draw a normal on the point of the incidence here, so the angle between the normal and the incident ray, that is the angle of incidence I. And as we know, as the light obliquely enter from one media to another, the direction of propagation of the light will change. Okay, so the light changes its direction as it is. Okay, now this is the point O where the light incident. Okay, and now the angle made between, so this is the refracted ray then. Okay, this is the refracted ray. So the angle made between the refracted ray and the normal, that is the angle of refraction R. Now this ray, okay, incident obliquely on the side AD of the glass slab, and again it is refracted, so there is a slight change in its direction. Okay, so and the light then, the refracted ray then reaches the another interface of the glass slab, the side of the glass slab B, C. And here what happens, so this is the direction of the refracted ray, and here this is the point where the two media, the interface of the two media, glass and air. So now this is coming out of the glass. That means what? Again it is going to change its direction. Okay. So from at this point, okay, this is the point of incidence. Here again the light will refract. Okay, it will change its direction. And if we extend the incident ray first, so this refracted ray will act as the incident ray for the second refraction, and the angle made between this ray, okay, this ray is called emerging ray. Okay, the ray that is coming out of the glass to the air is called as emergent ray, and the angle between this normal and the emergent ray is known as angle of emergence. And now if we extend the first incident ray, okay, like this, so we can see that the incident ray, the direction of the incident ray and the emergent ray will be the same, but that means these two rays will be parallel with each other, but they are slightly displaced. Okay, and this is the displacement taking place between the actual direction of the incident ray and the emergent ray. And if we observe this refraction of light, here also we can find this refraction take place by the agreement of some laws, okay, some rules. And the one, as we already know, okay, so the incident ray, refracted ray, emergent ray, all normal, all lie on the same plane. That is the first law of refraction. Okay, this is incident ray, refracted ray, and same plane. And second law of refraction, the ratio of sine of angle of incidence and the sine of angle of diffraction. Okay, the ratio between the sine of angle of incidence and the angle of refraction is a constant. Can written as sine I divided by sine R is equal to a constant, and this constant generally termed as the refractive index of that medium, also known as Snell's law. Sin I divided by sin R is equal to a constant, and this constant is generally termed as the refractive index of the second medium with respect to